Servus, I'm Nicholas, and today we will cover inequalities, which is a part of the WU BBE Entrance Exam preparation course covering the most important quantitative concepts. Before we start, I encourage you to navigate to our website in order to access all these tasks with written solutions. In the end, you will find even additional tasks if you want to learn more than what was covered in this video. Let's get started. The underlying idea behind the inequality task is that you need to find the solution set and pick the right solution set, which is in most cases provided in interval notation. Note that if the endpoints are included, the circles are filled. This represents the equal to part of the inequality and is represented by the square bracket. With this knowledge, we can move to the very first task. In the first task, we will solve together 3.1 inequalities. We need to solve the inequality 2x minus 5 is greater than 3. Consequently, we need to determine which of these intervals represent the proper solution set that satisfies this inequality. Given this inequality, we always search for the terms that contains the variable of interest. In our case, it's x. Therefore, we try to isolate the term that contains x. Doing that, first of all, we need to get rid of minus 5. To do that, we add plus 5 to both sides to not alter the meaning of the inequality overall. In the next step, we just simplify, meaning minus 5 plus 5 turns to 0 and 0 plus 5 turns to 8. In the next step, we need to divide by 2 in order to isolate x. The result is x is greater than 4. In the next step, we need to translate it into interval notation. The interval notation is 4 to infinity. Because x is greater than 4, 4 itself is not included, meaning we need to use a normal parenthesis. If the solution would be x is greater than or equal to 4, we would use a square bracket, but you will see that afterwards. If in the interval there is an infinity sign, plus or minus, we always use quote-unquote normal parentheses and never a square bracket. Keep that in mind. With this solution, we need to go through each single statement and determine whether it's true or false. The very first one exactly matches with the findings from the slide before, therefore A is true. If we go to the second one, B, we see there was used a square bracket. The square bracket means that x is greater or equal to 4. However, our solution is just greater 4. Therefore, this statement is false. Statements C, D, and E are obviously false as well. They don't match our correct solution set. 3.17 inequalities is a little bit more sophisticated than the task before. The task before was very easy, and this one has a little caveat to it. Let's check it out. We need to solve the inequality minus 3x plus 7 is less or equal to 1. How do we do that? First of all, we identify the variable of interest, which is x. We try to isolate x, and therefore we deduct 7 from both sides to not alter the inequality. In the next step, we simplify and obtain. We need to be careful. If we multiply or divide by a negative number, we need to switch the direction of the inequality sign. If you want to dive deeper into why the inequality sign changes the correction, I encourage you to take the BBE Insider course, which explains these little important things in more detail. But for now, it's sufficient that you know once you multiply or divide by a negative number, you need to change the direction of the inequality sign. In the next step, we just simplify once again and obtain the solution x is greater or equal to 2. This translates into the following interval notation. Watch out, as you can see, we use the square bracket on the left side because 2 is included in the solution set. As you see, it says x is greater or equal to 2. Therefore, this is the right choice in this case. Let's get back to the statements initially provided and compared to our solution set. The very first one messes up the direction. B contains a nearly true solution, but if you take a closer look, you see there was just used a normal parentheses. However, we need a square parentheses because 2 is included into the solution set. Consequently, C is the correct option. All other ones are false. Getting interesting. We are getting closer to the difficulty level of the BBE Entrance Exam. We have an inequality which has absolute value terms in there. How to solve those? Try it yourself, pause the video, and then you can compare to the solutions. Let's check if you could solve this example. When dealing with absolute value inequalities, you need to remind yourself of the following property. This one is very important to solve those kind of tasks correctly. The absolute value of A is less or equal to B translates to minus B is less than or equal to A is less than or equal to B. Why is that the case? Let's check it out. But before, let's revisit the absolute value of A property. If A is larger than 0, actually the absolute value of A is just A itself. But if A is smaller than 0, meaning if A is negative, we use a minus before the negative minus A, which in turn turns positive. The value of A is defined as the distance to 0, which is resembled by this property. Now we apply this property to the initial inequality, the absolute value of A is less than or equal to B. For that, we will check out two cases. The first case is the absolute value of A is equal to A, and the second case is that the absolute value of A minus A. As you can see, we have this statement here, which resembles our original statement, and we use A instead of the absolute value of A, and therefore this whole inequality translates into A is less than or equal to B. In the second case, the absolute value of A translates to minus A. We use minus A and replace it with the absolute value of A. Consequently, this inequality turns into minus A is less than or equal to B. If we multiply this inequality by minus, we can change the direction of the inequality sign and change the minus to B. If we turn that just around, we obtain minus B is less than or equal to A. Now we have a solution for both situations. For the first situation, where A is positive, the solution is A is smaller than or equal to B. This is resembled by this part of the inequality. Then, for the second situation, where A itself is negative, we obtain the solution minus B is less than or equal to A. This is the left part of this inequality. And this is how we obtain the property that the absolute value of A is less than or equal to B is the same minus B is less than or equal to A is less than or equal to B. With this knowledge, we can proceed to our initial task. Remember that the initial task was the absolute value of x minus 1 is less than or equal to 4. Now we just apply the property we learned before and apply it on the double inequality provided on the right hand side. We basically need to repeat the same steps as in task 1 and 2. We need to determine the variable of interest, which is x, and try to isolate this term. To do that, we add plus 1 to all sides. It's important that you really add it to all sides. Otherwise, you would alter the meaning of the inequality. We just simplify and obtain minus 3 is less than or equal to x is less than or equal to 5. Meaning that minus 3 is the lowest point on our interval and 5 is the highest value on our interval. Because we have the equal to property here, we use a square bracket on both ends. Now let's compare which statement contains the right solution set. The first one is obviously incorrect. The second one matches with our findings. The third one is incorrect. The fourth one is incorrect. And the fifth one looks correct on the first side, but it has no square bracket on the right hand side and therefore is not the correct solution. Task 3.3 of inequalities is the first one that covers a squared term. We need to solve the inequality x to the power of 2 minus 9 is smaller than 0. Try to solve this inequality by yourself and once again compare to the solutions afterwards. This is the best way to learn something. Try it yourself and then check the solutions. Don't go the easy way straight ahead, because you want to solve it yourself. You will need to solve it yourself on the entrance exam as well. Let's try to determine the right solution set together step by step. First of all, note that the inequality says smaller than 0, meaning that we want to find the value for x which makes this whole term negative. For that, a very useful tool is the sign diagram, which I will introduce you shortly. First of all, to use the sign diagram, we will need to find the critical points. To find those, we need to factor the quadratic. Note that the difference of squares formulas applies in our case. That means that x to the power of 2 minus 9 is equivalent to x minus 3 times x plus 3. Finding the critical points means that we try to find the value for x where this parenthesis turns 0 or this parenthesis turns 0, meaning that we need to find two critical points in our case. X plus 3 is smaller than 0 once x is smaller than minus 3. X minus 3 is smaller than 0 once x is smaller than 3. These are the values where these brackets turn negative. Why is that important? As soon as one of these parentheses is negative, the whole expression is negative. If both parentheses are negative, the whole expression is positive. We want to find the combination of those parentheses that make the whole inequality left-hand side negative, smaller than 0. For this, the best tool is the sign diagram. First of all, to make sense of the sign diagram, you need to understand how to use it. For each set of parentheses, you need to assign a horizontal line. In the next step, you draw vertical lines at the critical points. In this case, -3 is the critical point, and in the second case, 3 is the critical point. These critical points show us where the cutoff value is when this parenthesis is either positive or negative. For x minus 3, this parenthesis as a whole is negative once x is smaller than 3. Now we draw a red dashed line, or in whatever style you want to draw it, for this parenthesis when the corresponding x value leads to a negative value of the parenthesis. In this case, all values that are smaller than -3 correspond to an outcome where this term is negative. Now let's jump to the second term. The term x plus 3, represented on this horizontal line, is negative if x is smaller than 3. This term, represented by this horizontal line, is negative in the case when x is smaller than -3. As you see, the critical point -3 is right here, and if x is smaller than -3, now we should draw right again to make things consistent. We have the term being negative on here. Note that because we have a strict inequality, we do not include the endpoints. The critical values -3 and +3 divide our number line into 3 intervals. The interval x is smaller than -3, the interval between -3 and 3, and the interval x is larger than 3. Now, as we know, if there is a red line here, it means that this term is negative. Remember that we multiply these two terms, meaning that if one term is negative and one term is positive, the overall expression is negative. If both are negative or both are positive, the whole expression is positive. Now, let's apply this in the sign diagram. As you can see right here, we have a negative and a negative value resulting in a positive overall expression. In the next case, we have a negative and a positive value on the interval, leading to a negative overall expression. In the last case, both terms are positive, leading to a positive overall expression. The initial expression was concerned about all values that are smaller than 0, meaning that are negative. Therefore, we check when the overall expression is negative. It's not the case in this interval, it's not the case in this interval, therefore just the interval -3 is smaller than x is smaller than 3 is the right interval because all values in this interval are negative. Now we need to remember that. Try to turn it into interval notation by yourself, and we will quickly jump to the solutions. On the right hand side you can find the sign diagram from before. This translated into interval notation is the same like -3 to 3. Note that we don't include the endpoints because we have a strict inequality. Therefore, this one is correct. This one seems correct at the first place, but once again we have a square bracket here, and therefore it's not the same one. All other ones are obviously false. The next task is concerned with a fractional inequality. We will identify the critical points once again analyze the signs, and finally write out our answers in interval notation. Try it again one more time. Click pause right here and I will start with the solutions. The very first step, once again, is to identify the critical points. Setting the numerator equal to 0 helps us to obtain the very first critical point. The first critical point, when rearranging for x, is 1 over 3. The second critical point is -2. Note that we can't include -2 in the final solution set because this would lead to a division by 0. And as you know, a division by 0 is not defined in the set of real numbers where we are working in. We will create a sign chart once again. First step, we note the critical values and draw vertical lines below them. The first one is 1 over 3 and the second one is -2. As we deal with a non-strict inequality, we can make filled circles under 1 over 3. With the critical point -2, we can't do that because this would lead to an undefined expression. Therefore, the circle keeps open, meaning it is not included. Next, we split the number line into 3 intervals using our critical points. In the next step, we will analyze the sign of the fraction in each interval. For the first interval, 3x minus 1 is negative and x plus 2 is negative as well, making the quotient positive. For the next interval, the numerator is negative and the denominator is positive, making the overall fraction negative. The last interval, both factors are positive, leading to a positive fraction in the end. For the initial assignment, we are concerned with values that are greater than or equal to 0. Therefore, these intervals are of our interest. We need to combine -infinity to -2 plus 1 over third to plus infinity. Note that 1/3 is contained in the solution set. The sign diagram is once again provided on the right-hand side. We need to find the union of these two intervals. If you watched the prior videos, you're already familiar with the union sign. Comparing the results with the options provided, we see that the option C exactly matches our solution. The other options either incorrectly include or incorrectly exclude a boundary point, making the solution set incorrect. I am interested if you could solve this inequality by yourself. Let me know in the comments. As you are familiar from the other YouTube videos from this BBE Entrance Exam preparation course, in the very end, you are provided with a set of statements you should solve yourself based on the knowledge you acquired throughout this video. I won't spoil you with the solutions in this video, and of course you want to check if you got everything correct. Feel free to do so with the solutions provided on our website. You can get them just by scanning this QR code or clicking on the very first link in the description of this YouTube video. If you do so, you will be redirected to our website where you can sign up for free for the free sample paper, where you can find the solutions for this YouTube video, all other YouTube videos, and even some statements which are concerned with economics and English. I highly appreciate the effort you put in to watch this video until the very end. You are invited to follow the channel to not miss out on any future videos which are part of the WU BBE Entrance Exam preparation course. If you enjoyed watching this video on equalities, you will for sure love this one as well.